Hi guys, we are going to continue our discussion on how to solve two unknowns, two equation, but we're going to start learning about some techniques that help us systematically solve these types of equations. The method that we're going to learn today is called elimination. Basically in this method what I do is I will try to add, subtract, multiply, divide my equations in a way that if I add them together or subtract them from each other, I get rid of one of my variables. So I eliminate one of my variables. That's why this method is called method of elimination. And if I do that, I will be left with one unknown and one equation, and I know how to solve that pretty easily. So let's start with our first set of equations. So I have this equation called, if you look at it, we have 2x plus y and we have x minus 3y. Not very intuitive on how to solve them. If I add them together directly, I get 2x plus x make 3x, and plus 1y minus 3y make minus 2y equals 8 and 4 make 12. Not very useful. I got another two unknown two equation. Not very useful. I don't want to do that. But if I look here, I have a negative 3y. If I somehow can get 3y from this equation, if I add these two together, they will eliminate each other. So what I'm going to do is I'm going to multiply this equation by 3, and I have to remember that when I multiply an equation I have to multiply both sides. So let's do that. Let's multiply the equation on top with 3. If I do that, I get 3 times 2x plus y equals 3 times 8, and 3 times 8 I know it is 24. But here I have a law called the distributive law. Whenever I'm multiplying something over an addition, this multiplication gets distributed on both variables. So this 3 gets distributed over every parameter in this parenthesis. So 3 first gets multiplied by 2x, then by y, and this will give me 3 times 2x becomes 6x, and 3 times y gives me 3y, and this addition remains the same. And when I do that, I get 6x plus 3y equals 24. Now I can see that I can add these two, and if I add them, plus 3y and minus 3y cancel out each other, and I will be left only with 6x plus x, which is 7x. So I'm going to do that. I'm going to add them, and I will get 7x equals 28. Remember, 3y and minus 3y cancel each other, and 6x plus x makes 7x. I get 7x equals 28. This is the one unknown one equation that is the combined solution of these two equations. So these two equations, their x can be solved through this one unknown one equation, and I know how to solve this equation from our discussion on how to solve one unknown one equation. This gives me x equals 4. Okay, now that I have x equals 4, all I need to do is take any of these equations, whether this one, or our original 2x plus y equals 8. Let me make it better. X got worse. Okay, 2x plus y equals 8. I can use any of these equations and basically plug in my 4 in x equals 4 into the x value of any of these and get my y value. Basically I will reduce that equation also to another one unknown one equation. In this case I'm going to use this equation. Alright, so I have x minus 3y equals 3, and I'm going to substitute my x into this equation, and I will get 4 minus 3y equals 4, and that is another one unknown one equation, and from our discussion on one unknown one equation I know how to solve that pretty easily, and if I do that I get my y equals 0. So basically I've solved my two unknown two equations, and I found my proper values for x and y. X equals 4 and my y equals 0. And in the next lecture we're going to discuss on how to solve two unknown two equation. We will use the same equation but use another method called the method of substitution. See you then.